Hello friends, this is Jim with Science Talk, and I have a kind of a really cool story to share with you. NASA is going to be sending a helicopter to Mars. Here's what it will do. So now, this is really cool because there are certain engineering challenges that must be met. So for example, the biggest one being the extremely thin Martian atmosphere. Most aircraft, planes, or helicopters require some sort of a lift to sustain the craft off the ground in the atmosphere. And in the case of Earth, the Earth has a considerably thicker atmosphere, so it's able to do so more readily. I'll give you the details on this in a few moments. So, NASA is going to include a small autonomous helicopter in the agency's upcoming Mars 2020 rover mission. The craft will undergo a 30-day test campaign once it reaches the red planet to demonstrate the viability of travel above the Martian surface with a heavier-than-air craft. They've already demonstrated very well that rovers can roll around on the surface quite nicely, and they've been an amazing success. So NASA's administrator, Jim Bridenstine, said that NASA has a proud history of firsts. The idea of a helicopter flying the skies of another planet is thrilling. The Mars helicopter, or Marscopter, holds much promise for our future science, discovery, and exploration missions to Mars. So says Administrator Bridenstine. The development of this craft began in 2013 at NASA's JPL, Jet Propulsion Laboratory in California. It's just under 4 pounds, about 1.8 kilograms. Its body is about the size of a softball, so it's not very large, kind of more of a drone, really. It will carry solar cells to charge up when there's light, and a heating mechanism to deal with the cold Martian nights. The helicopter's twin blades, and this is how they hope it will maintain lift, will spin at about 10 times the rate of a helicopter's blades on Earth, basically 3,000 RPMs. That is extremely fast. So other challenges to go with that is keeping the bearings well lubricated and keeping the lubrication from becoming too viscous, gumming up too much. And also you want to keep the bearings sealed so you don't get any of the Martian dust and other contaminants in it that could wear out the mechanisms. The altitude record for a helicopter flying on Earth is about 40,000 feet, approximately 12,000 meters. Mimi Ong, who is the Mars Helicopter Project Manager at JPL, made that statement. She continues, "The atmosphere of Mars is only 1% that of Earth, so when our helicopter's on the Martian surface, it's already at the Earth's equivalent of 100,000 feet in elevation." You can see where the challenges are to have a craft stay aloft. To make it fly at that low atmospheric density, we have to scrutinize everything, make it as light as possible while being as strong and as powerful as can possibly be. Mimi Ong adds. Mars 2020 is slated to launch in July of that year on United Launch Alliance's Atlas V rocket from Cape Canaveral, and the mission should arrive at Mars in February of 2021. It will be a 6-wheeled rover that will look for signs of habitable environments as well as sites that might have once contained microbial life. There will be 23 cameras on board. There will be a microphone and a drill to collect samples. The helicopter will ride to Mars attached to the rover's belly pan. Once the rover reaches the planet's surface, it will place the helicopter on the ground, move away to a safe distance in order to relay commands. Controllers on Earth will then direct it to take its first autonomous flight. Now, Mars and Earth are separated by several light minutes. So it's not going to be instantaneous. It's not going to be like a guy with a joystick and doing controls in real time. There's a delay. So you don't have the luxury of a pilot, and you can't really joystick, right? You can't really use a joystick to operate this thing. So all you can do is give it commands and let the autonomous capabilities take over. So the autonomous capability will receive these commands, interpret such commands, and then fly, undertake its mission. The helicopter is going to attempt up to 5 flights, going further and operating for longer each time, up to a few hundred meters and possibly 90 seconds of flight time. It's going to try and climb to about 10 feet, 3 meters above the ground, and hover for approximately, or try to hover for about 30 seconds. Now, the main mission is the rover on the ground looking for microbials, possible microbial life signs and so forth. That's the main mission. The helicopter, if it's successful, it is high risk. If it is successful, will be a bonus. Okay? So if it fails, it's not going to affect the rest of the mission. If it succeeds, then there's a new tool at the disposal for astrophysicists to use. Allowing for perhaps to reach previously inaccessible regions that's too difficult to drive over above perhaps rocky terrain. So if it succeeds, it'll be an added bonus and it'll be really cool. So I wanted to present that to you, and I am definitely looking forward to this mission taking place, and it'll be really cool to see what comes of this. Thank you for your time. We'll talk soon. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below.